All right, so we're continuing our study of parallelograms, and in this we're going to talk about rectangles and rhombuses. And these are the two kids of the parallelogram. So the parallelogram had two kids, rectangle and rhombus. And these have properties for sides, angles, and diagonals. So in a rhombus, the diagonals are going to bisect the angles, right? So these two angles would be congruent to each other. These two angles are going to be congruent to each other. The diagonals are going to be perpendicular, so where they intersect are going to be perpendicular. So this is a unique thing because the diagonals in the other lesson had to do with side lengths. These diagonals create angle properties. So in this case, this intersection is going to create four 90-degree angles when they intersect. Okay? So using these two, we can do a problem such as this. So we know that all the intersections of a rhombus are going to be 90 degrees. Okay? And then we know that this is going to be the same as this. So if this is 90 and this is 50, that means this has to be 40. So if this is 40, this has to be 40 as well. Okay. And if this is 50, this is going to be 50, and then this will be 50. So if that makes sense, these two are 50, these two are 50. And again, if this is 100, this will be 100, and opposite angles are congruent in a parallelogram, and a rhombus is part of a parallelogram. So hopefully that makes sense to you. This is 40 because a triangle equals 180, and we're given 90 and 50, so if we subtract that from 180, we get 40. This gets bisected, and then these two angles are going to match up to here in a rhombus. Okay, so a rhombus is really like a big reflection of itself. All right, here we look at this. We know that if this is 120, all right, and a rhombus has all sides that are the same. So by definition, a few lessons ago, we talked about how a rhombus has four congruent sides. That means this triangle up here is isosceles, okay? And so that means that out of 120, we have 60 degrees left over. So we know that these two angles will be 30, and because the diagonal bisects angles, angle 2 and angle 4 will also be 30. So we use the properties of that the sides are congruent and the diagonal is an angle bisector to get that answer right there. All right, now we talk about rectangles. So the diagonals of a rectangle are congruent. So the entire diagonal length is congruent. But now if you look here, the diagonal is not an angle bisector, not in a rectangle. So you can tell by looking at the 90-degree angle that these two parts are not the same. Okay, so keep that in mind. The length of both are congruent though, so we're going to use that to solve an equation. All right, now this property here is actually pretty useful. So if we had a closet door and we wanted to drill a hole in here to put a handle, when you buy them at the store, they typically don't have handles drilled because it depends on the knob you use. But if you had a single knob, a single screw knob, without a ruler, if you just draw lines from corner to corner of the rectangle, it would intersect at the exact center of the rectangle. So that would be a way to find the center of a rectangle without using a ruler. Okay. All right, so since diagonals are congruent, we can set them equal. So FD is this whole length, and GE is this whole length, and we can set them equal to each other. And we get Y is equal to 3.5. And all it asks for is the length of the diagonal, so now we have to plug it back in to get your answer. So 3.5 plus 5 would give you a length of 8.5. So make sure again you read the questions carefully. These three theorems here are what we talked about in the last lesson, where we don't know what shape it is, but we know what properties the shape has. So because we know what properties it has, we can determine what the shape is. So these are just reiterating what we said, just in a different way.